All right, take it away, Joe.
All right, we've got one thing I want to talk about on service support, which I should write up some more info about before I talk about it. And then Ian's got carryover from the last call about auto allocation. Ian, you're here, right? Yeah, maybe we start talking about that and I'll write up some more about my topic so we're not in the dark. And then if anyone else wants to talk about anything, just add it to the agenda.
Sure. What was everybody in the last call, like for the quick summary that we did at the very end of this change? Should I review it for this one?
Just recap. Maybe better to recap. Yeah.
Yeah. Okay. Fair enough. So basically, service entry auto IP allocation, we're working on a new version of it that will provide the stability by persisting the auto-assigned IPs into the service entry's status. The present implementation assumes one assigned set of IPs per service entry. But the old way that this worked internally was doing it differently and was providing a unique IP for each host in the service entry. And so the proposed change is to basically allow us to map IPs to hosts instead of just having one set of IPs for the entire service entry. And this will allow us to sort of have a smoother transition between how it worked the old way and how the new one is going to function. So does that make sense for folks? Are there any questions? All right. So yeah, anyways, there's a pull request for this. If you're interested in the topic, please go ahead and take a look, leave comments, questions there if you don't want to bring them up on this call. And then, yeah, I'm working on the Istio changes in order to sort of prove out that this is going to do what we want. So hopefully PR sort of pending there soon.
Ian, will this affect sidecars as well? Yes, it's consistent behavior.
Yeah, it should. So it's going to be very helpful for Ambient because this functionality, the old way it was implemented, doesn't really mesh with Ambient much at all. And then it will be viable for sidecars. The changes will affect the generated Envoy config as well as the WDS config that goes to ztunnel.
Thank you.
And then I guess just the final call out is we would probably like to cherry pick this to 123 since we haven't actually shipped a version with the old API. So I don't know that would be a huge problem. It's a change that we haven't shipped and it's in status, but just sort of a heads up if there are release managers on the call. All right, cool. I guess that's all. If you have questions, like I said, you can put them in the PR or Slack me if you don't want to bring them up on the call. Thanks.
Thanks, Ian.
All right. Cool. Yeah, that makes sense. Looking forward to testing that out. This next one I want to bring up, it's pretty in the weeds, but I just wanted to get some second opinions on it. So for some context, Kubernetes has this field in service, which is called publish not ready. I think it's actually called publish not ready endpoints or something. It's kind of a niche field. What it does is that even if the pod is not ready, it's still accessible in the service. To be honest, I really don't get why people use this, but the one case that I specifically saw of an ambient user that reported it was with Vault, where they have to like unseal the Vault, and they do that by calling the Vault service, and the Vault is not ready until it's unsealed. Again, I don't understand why they set it up that way, but they do. And one of the goals with Ambient is to be compatible with Kubernetes. So there's reasons we would want to support this. Now, how this works in Kubernetes is that this just impacts the endpoints controller. So it will just make these as endpoints. And how it works in Istio sidecars is we read endpoints. And so we don't actually have any code that supports this feature in Istio, but we also don't need to because it just kind of works out of the box. But in Ambient, we don't have endpoints. We just have workloads, which are like a pod, basically, and services. Endpoints is like the joining of those two, and we actually do that join in the data plane itself. So we don't get that for kind of free like we do with sidecars. So the health is a workload level thing, and then we do a join like the same way that the endpoints controller would in Kubernetes API server, but we do it in the data plane. So I was thinking like an easy way is we could just go add some field into the ambient service. It's like publish not ready endpoints, true or false. Like we can bike shed the API name. It's probably not that exactly, but we can come up with something. And then we just go implement this in ztunnel. But I was trying to think if there was maybe some benefits to making the API a bit more aligned with how Kubernetes does things and moving health to be a per service. Like in the, well, let me show an example. Well, I guess we're not sharing, so hopefully people have the doc app. So like workloads has a list of services that it's associated with. So I was thinking maybe we put a health inside of that list, so it's on a per service basis. The thing I was thinking is that it's actually theoretically possible for a pod's health status to not be aligned with the endpoint's health status. Like this is one example that's very clear and defined in the core V1 APIs. But hypothetically, there could be other cases. I don't know of any though, aside from like eventual consistency where there's just a delay in updating endpoints, which is actually potentially maybe a good thing that we're faster than relying on that eventual consistency. But it would future-proof us against these changes. So I don't know. I just want to bring this up. I asked Rob from the Kubernetes team if there was any other cases that are important that we should consider here, but wanted to see if people had any ideas on when this might matter or if we should lean one way or the other.
So this sort of just moves like the load balancing decision making. Like if we did it with this the pod level health status within the service, then like ztunnel can. We're not relying on Kubernetes to like just exclude the thing when it's not ready anymore. We have to make our own decision about, oh, this one's ready, so I will use that versus not. We could do our own sort of load balancing, deciding whether we want to send to a healthy endpoint or not. Right? That's what you're saying by insulate, right? We just basically don't. We get all of it, and we don't worry about whether Kubernetes is like obfuscating or the service is obfuscating or whatever, or the control plane. We're just making a decision.
Are you talking about option 1, putting it in service, or option 2, putting it in a workload?
In the workload.
Okay. Yeah, what I was thinking is the implementation of this would be in Istio D. We would look at the endpoint status.
Yeah.
And so we would be relying on Kubernetes, actually. Like we wouldn't care anymore about the pod health. We would only care about the endpoint health, which is obviously derived from the pod health by Kubernetes, but in theory, it could be different. It's definitely, like this model is definitely more flexible. I just don't know if it's a level of flexibility we actually need.
Yeah.
Like it is more complex. Like it's pretty easy for us to just go slap another genome field on the service. That's like, do we allow the unhealthy ones or not? And then in ztunnel, it's it's literally like a one line change. No, it wouldn't need to know the difference, but it would just be if this is set, filter out unhealthy ones or include healthy ones, or I don't know, whatever, you know what I mean? Include or not include unhealthy endpoints when we're doing the load balance.
Does ztunnel filter? Are they? I thought the unhealthy ones were already filtered out before ztunnel gets them, right? I thought we don't give them
No,
to
we need to
zTunnel
send
and
the
then-
unhealthy endpoints to zTunnel.
We
Because
need to.
otherwise,
We don't currently, right?
no, we do currently.
Okay.
Otherwise, it would, like a pod would start up, it's not ready yet because it's not sending traffic, and then it would never become ready because it doesn't even have the workload.
Okay. I thought we had some check on pod status before we send it in WDS, but I could be wrong. All right. Fair enough.
No, we just send a status that is the health of it. So we do check. It's just we always send it regardless. So we
Okay.
just send it as healthy or unhealthy. I think a long time ago we didn't have that, but then it was causing issues.
Yeah.
So.
I'm thinking back, I know we've had a number of occasions where pod readiness didn't give us the best signal in terms of whether that endpoint should be serving traffic. But I feel like in most of those cases, what we ended up doing was improving pod readiness, right? Or think of like .NET JIT, the just-in-time compiling. It'll mark itself as ready, even though it technically hasn't compiled anything except for the readiness endpoint. But in general, we've come up with tooling that will cause that pod to not mark itself as ready until all of the caches are warm, the compilation is done, etc. So if we had had this years ago, I can see how it might have been particularly useful, but I'm struggling to think of a case today where pod readiness is not a sufficient signal for us.
Yeah, and even if we did do the workload-based approach, it's still using the pod readiness. It's just indirectly. It's just that Kubernetes reads the pod readiness and updates the endpoint's health rather than us doing it.
Okay, so they're not expected to have different values.
Yeah, I mean,
than
that's
with
the thing
eventual
is, like,
consistency.
hypothetically, they could, but I just don't. I think the only case where Kubernetes will actually do that is with this publish not ready thing, and so I'm just not sure if there's actually legitimate cases where they do differ. Like in theory, you can turn off the Kubernetes endpoint controller and do whatever you want, but why? Like that's not, it's kind of a mismatch of expectations on how Kubernetes APIs work. Obviously, at any point you could turn off some Kubernetes controller and make a new deployment controller that doesn't make replica sets, but I don't know that we need to design around that necessarily. But maybe we do. That's kind of what I was trying to figure out in this discussion, is if there's edge cases that I'm just not considering here. So far, it sounds like no, which is what I was kind of leaning towards as well. But I'm also not going to have time. I mean, someone else could pick this up if they want. I personally probably won't have time for at least a week or so we can think on it. And if anyone comes up with some cases, let me know. Otherwise, I'll probably towards proposing the service approach.
Is this field new in 130?
No, this one has been around for a long time. It's just pretty niche.
Okay.
Yeah, the new one is the traffic distribution, which we already support, which lets you keep traffic within the local zone. So
Nice.
That is very nice. By the way, so if the service is published not ready, and assuming we can recognize or we can store that status in Istio, would the user wants the traffic to send to the pods? I assume no, right? Because there's no pods that I can actually serve the traffic.
that's the thing. That's what they want. They want to send to the unhealthy pods.
Oh, okay.
I really don't know why. Like, I don't fully understand the use case of it, but that's what the field does.
Okay, got you. So that's why
I think it's usually used for like these like stateful clustering database type things that have like their own concept of health that's totally outside of Kubernetes and just wants to connect everything together and figure out what's healthy or not outside of Kubernetes concept.
Got you. Okay, that's why unhealthy is not going to be helpful in this case.
Yeah, but at the end of the day, like, it's also why they're doing it. It doesn't terribly matter that much. It's more like, this is a first-class fielding service. We are kind of the service implementation, so we kind of have to support it. Now, that being said, this is not the only field and service we don't support. The other one, let me see if I'm missing one, is the affinity. So that's something we could potentially add, but we don't support today. I believe affinity and publish not ready addresses are the only two we're not currently supporting, though. So if we get those done, then we would, as far as I know at least, be fully compliant service implementation. Well, not fully compliant, like we don't support UDP, obviously, but of the things that we touch, we fully support them. But so far, I haven't heard anyone complain about session affinity, and it's very hard to implement, whereas this one is very easy to implement. So I'm kind of holding off on session affinity personally. It's also not supported in sidecars. So.
And this one is not supported in Sidecar either, is that right?
It is supported in Sidecar, interestingly, because in sidecars, we only look at endpoints, and Kubernetes implements this in the endpoints controller. So we are hitting it at a layer that has already applied the logic. The problem with Ambient is that we look at the higher level objects instead of the lower level objects. And so we have to do some of that same logic ourselves.
Okay, yeah, that makes sense. Thank you.
And
Cool.
if we did get it into a situation where we needed to do that, that's the option B, right? Where we sort of add endpoint status implicitly into the mix so that we're not broken if they do something else like this. But we don't need to do that yet.
Yep. Okay, that makes sense. Cool. Well, we've got 38 minutes. Anything else people want to discuss?
All right, looks like no. So should we just wrap this up? Thanks everybody for joining. Bye.
Thank you.
Thanks. Bye.